Hello and welcome everyone. In today's episode, we are going to explore the Google Cloud Tasks. So, by putting first thing first, let's get started with the question. What are Google Cloud Tasks? Google Cloud Tasks is a powerful service that allows you to offload the tasks that would otherwise slow down your user-facing code. By user-facing code, I simply means the user experience of your application. With Google Cloud Tasks, you can optimize your application for efficiency and speed, and leading to an overall more responsive and enjoyable user experience. You see, sometimes our applications have to perform some tasks that are time consuming or can be deferred. These tasks can be anything from sending out bulk of emails to processing complex calculations. And that's where the Google Cloud Tasks comes in. They essentially allows us to defer these tasks, freeing up your application to swiftly respond to user interaction. But where do the Google Cloud Tasks really shine? Well, they shine in the multitude of scenarios. Perhaps you need to process a task that is compute intensive or long running, or maybe you want to schedule a task to run in future at a certain time. Yes, just like an alarm clock, but instead of waking you up, these cloud tasks wake up your application to do some important task. Now, you may be thinking, could I achieve something similar with periodic polling refreshing after 1 or 2 minutes? Yes, you could, but Google Cloud Tasks comes with enhanced efficiency, reliability, and most importantly, they are designed to scale with your applications, making them a far more powerful choice for your application. So let's dive a little deeper. Today in this episode, we are going to explore how can we make use of Google Cloud Tasks to manage the time to live or TTL of a Firebase Firestore document. Sound exciting, right? So let's see a demo of the application that how the Google Cloud Tasks can improve the performance of the application without making the load on the UI. So for the demo of the application, I have this simple Instagram-like application where I can create the post and also I can get the post right here in the activity tab. So when I create the post in here, so a background function will be triggered and this will schedule the post for future to be disappeared from the Firestore database after 2 minutes. So I have implemented this functionality and you will see how we can do this in the future episodes of this series. So let's type something in here and let's say schedule post for 2 minutes and let's upload this. So after uploading this, simply come here to the activity tab and we got this post right in here. And this post is scheduled in the cloud task and will be disappeared after 2 minutes. So let's also go to the Firestore database to see it in there. So that is the Firestore and that is the document created in the TTL post collection. Let's restart this. So we got that collection in here and that post. So when the 2 minutes has been done, so this will be deleted from the Firestore database. So let's wait for it for only 2 minutes. You can see the post is deleted after the 2 minutes has been done. So that's what we are going to achieve in this series. And using these cloud tasks, you can also achieve something like event scheduling and also some other stuff in your own projects. And also, if you see in the Cloud Firestore database, the document is also deleted from here. By the end of the video, you will have an in-depth understanding of Google Cloud Tasks and you will be able to implement them in your own projects, making them more efficient and user-friendly. So, are you ready to take your application to the next level using Google mind-blowing technologies? Fantastic! Let's jump right in and explore this amazing service of Google together. Hello and welcome everyone again to the second episode of Google Cloud Tasks. So in this episode, before going forward and setting up everything with Google Cloud Tasks, there are some prerequisites that you need to carry out before doing so. The first prerequisite is you must have a Firebase project created and must be fully functional working with your Android or iOS application. And the second one is the document you want to make TTL or time to live. There must be 2 fields included. The first one will be expire time and the second one will be expire in milliseconds. The expire time will be simple Firestore timestamp and the expire milliseconds will be the same timestamp but will be stored in the milliseconds. So these are the two prerequisites that you need to carry out before setting up everything with Google Cloud Tasks. So having this in mind, let's go and set up everything with Google Cloud Tasks. So first of all, open your browser just like this. It can be any browser, and simply in the URL search for Google Cloud Console. After this, something like this will appear in front of you. Simple, open this Google Cloud Platform. The Google Cloud Console is a graphical user interface provided by Google Cloud Platform for administrating and managing various services and resources in the Google Cloud Platform. So that's it for the Google Cloud Console. So I told you must have created the Firebase projects. So after navigating in here, simply you need to select your Firebase project in here. I have selected my Instagram social graph. So just like this, you have to select your Firebase project that is fully functional, working with your Android or iOS application. So after this done, simply in the search bar, you have to search for Cloud Tasks API. After this, you will see in the marketplace something like Google Task API. Click this and this will navigate you in here. So after it's been loaded, you will see the Google Cloud Task API in here. For me, it's saying try this API and manage this. And also a badge of API is enabled. So in your case, it will not be like this. It will say enable the API. So as this Google Cloud Task is a paid product, so for that you need to enable the billing for your project. So you need to enable the billing so you will be allowed to use the Google Cloud Task API in your project. And there are some key points about billing that you need to keep in mind. The first one is task execution. In the Google Cloud Task, we have the queues, a data structure where we queue the task and the tasks remain in the queue until their scheduled time arrives and they are dispatched from here and perform some specific task. So on every task execution, either that is creating, updating or deleting the task from the Google Cloud Task queue, it will be counted towards billing. So that was the first one. And the second one is task queue, the number of active queues and their configuration, such as the number of tasks and their retention period, is also will be counted towards billing. And the last one is the task payload. The size of the task payload and any data associated with the task will also be counted towards the billing. So you need to keep all of these things in your mind in order to avoid the overusage of Google Cloud Task API. Otherwise, it can be harmful for you. So these were some key features that you have to keep in your mind before working with Google Cloud Task API. So having this in mind, your API is enabled. Next thing you need to do is to go back from here and simply, instead of Google Cloud Task API, search for Cloud Tasks. And you will see something like this, asynchronous task execution. Simply click this and this will navigate you to a page of Google Cloud Task. I have one queue created named Schedule Post TTL. So when you come here, you have to create your queue. So later we will enqueue the task there and that will still in that queue for their scheduled time arrives. So here to create the queue, you will see the option create push queue. Simply click this and this will navigate you to one more page. Here you need to name your queue and select your region that is near you. I have selected the US Central one, so you can select the one that is near to you. Next, after naming the queue and selecting your region, simply create this and a queue will be created just like this. Here I have one. Simply after creating the queue, click this and this will navigate you the queue in here. And here are some more details about the queue. We can refresh the queue, edit the queue, pause the queue and also delete the queue. And also purge the queue. And the delete task and run task are disabled for now because we have not yet selected any task and there we don't have any rows of tasks to deal with, like to delete or run that from here. So here you will see the US Central one, the location of our queue and the type of our queue, and also the task in the queue. For now we have nothing but 0, and in the task running we have no task running, so this will simply just like this and completed in last minute, like the tasks that are completed in last 1 minute. So will be appear the number of tasks in here. So we don't have any, so we have again the 0. And we have again the configurations for the task, the location, the maximum rate, max concurrent, 1000 max burst size. So these are the configuration for a queue that we have created, and that is the task. There will appear our task in the queue that will be included in the queue and will be appear here and will still there up until their scheduled time is arrived and they are dispatched. And next we have the logs, and we have to enable the logs. And here is also a warning: queues may generate a large number of logs and can increase the cost. So this feature is off by default, so you can enable it on your own risk. So if you really need to see the logs of your task queue, so simply you can enable this. And if you don't want to do this and want to avoid the increasing of billings, so simply you can avoid this, and by default it's off. And in the matrix you can see the matrix of your queues, the completed, failed and least and all of that stuff. So that will be the place where our task will be appeared when it's included in the queue. So that was some simple setup or configuration for the task queue. After this done, in the next episode we will go for setting up the cloud functions of the Firebase, and will write the cloud functions and will make the Firestore document TTL, and you will see it practically in the next episode. So that was it for this episode, and surely in next episode we will start writing cloud functions, and that will finally be the part of the code. Hello and welcome everyone in the third episode of Google Cloud Tasks. So in this episode we will be finally writing cloud functions to make our Firestore document TTL. But this requires one more thing: you must have the cloud function set up for your Firebase project. So if you don't have, there is no need to worry, because we are going to do it from scratch. So let's jump right in. So first of all, in here you have to create an empty directory in your system and simply name it according to your Firebase project name or anything you want. Simply name it Instagram backend, and let's rename it to remove this parenthesis from here and put one more underscore. After this, simply you have to open up your terminal. So I will open the terminal. If you are using any operating system, simply open the terminal for that and simply use the cd command to navigate to this directory. First of all, I have this directory on my desktop, so I will go for the desktop and again cd Instagram backend. So now I am in this directory now. Now here you need to run some commands for setting up the cloud functions for your project. The first command here that you need to run is the npm install globally Firebase tools. Install the Firebase tools globally in your machine. Simply hit enter and this will install the Firebase tools globally in your machine. So let's wait for it until it's done. So after the Firebase tools has been installed, there is one more command that you need to run. That is Firebase login. If you're not logged in with your account, simply you have to log in. After running this command, this will ask for login with your account, the account where you have created your Firebase project in the Firebase console. So simply log in with that account, so you'll be allowed to set up the cloud functions for that project in this directory. So I already have logged in, so simply I will ignore this, and after this there is one more command that we need to run, and that will be the final command to initialize the Firebase functions for our project where we want to write the cloud functions. So simply also run this command. That command will be Firebase initialize or init functions. Simply hit enter. So here it is going to require some configuration for that. It's asking for use an existing project, create new, add Firebase to an existing Google Cloud Platform project, don't set up a default project. So I will select use an existing project because I do have one project in Firebase that I have shown you in the previous sections where we were just seeing the demo of the application. So simply I will use an existing project, and here it will show all of my existing project in my account to which I have just logged in. So simply I will select my Instagram social graph from here and simply hit enter to go for that. So it will wait for some few seconds, and then it will ask for what language would you like to use to write Cloud Functions. So simply I will select the TypeScript. So you also have to select TypeScript because that's a beautiful language and give us a simplified way to write code unlike the JavaScript. So simply select the TypeScript and hit enter. And then it will ask for, do you want to use ES to catch portable bugs and enforce style? So simply I will select no and go for that. And again it's asking, do you want to install the dependency with Node Package Manager? Now I will simply go for yes, install all of the dependencies that are required. So again we have to wait for some time after it's done. So the final message of this Firebase function initializations is Firebase initializations complete, and it has successfully initialized the Firebase functions for us. Now we will be able to write the Cloud Functions for our project. So that's it. Next, before going forward for writing the Cloud Functions, here let me show you one thing. That is the same project. Remember from the first video of this series. So for now it's not working. Let me show you how. When I create something like, hey, disappear after 2 minutes and upload this, and it will come in here and it will never disappear and will remain in the Firestore because we have not write the logic for that yet. But in the demo, there were the logic that I have shown you. So in the upcoming episodes, we will be writing the same logic, and you will see it practically that how we can make a Firestore document TTL. And also, not only this, we will also look for how to cancel the already scheduled task as well as taking care of the potential issues of security related to the HTTP request. So you have to stay tuned in order to not miss all of the things that we are going to learn in this series. So anyways, this is the Firestore, and let's reload this. And same in the TTL document, we got a document, and here we have created this post with the description, hey, disappear after 2 minutes. And here let me show you my schedule post queue. Here will comes no task and no scheduling because we don't have any logic now. And we are going to write the logic for that, so we will be able to enqueue the task in here, and this will be dispatched at the right time that we have scheduled, and it will delete the document from the Firestore database. So let's see how this is going to be. So open this directory in the VS Code or the WebStorm or any editor you like. So I will open this Instagram backend in my VS Code in order to write the Cloud Functions for our project. So after opening up the directory in the VS Code or any editor, you will see a simple welcome page and some directories created by the commands that we have run some few minutes before. Here you will see the directory of the functions. Let's open it, and you will also see the source directory. Let's open it up, and the index.ts, that's the default some code written in here. So here will goes our exports of the functions, and we are going to follow the separation of concern to separate each Cloud function in the separate file and not mixing up everything in the index.ts. So let's keep everything just as it is, and let's go for installing some necessary dependencies that we are going to require along this project. So let's open up the terminal, and first of all here you need to navigate to the functions. Go for cd functions, and now we are in the functions directory. And now this is our package.json. If you have ever worked with the Express.js or something like this, creating some basic APIs, so you may be familiar with this. So if you didn't work with this, there is no need to worry because we are going to do everything from scratch. So here in the functions, we are going to install some necessary dependencies. The first dependency that we are going to work with is going to be the Google Cloud Tasks, because we are going to schedule or enqueue a task in the queue, so that will be dispatched at the right time and delete the document from the Firestore. That's it. Now let's go for installing, and we have to run npm node package manager install *google cloud /tasks, and also save to save it in the dependencies. Now hit enter, and this will start installing the dependency of Google Cloud Tasks. And you can see we got the Google Cloud Task in here, which is what we are going to use later for scheduling the task in the queue. And also there is required one more dependency, that is the Google Auth library. And you will see this why we need this in the last episode of this series. So for now, let's install it. npm install Google Auth library. Install it and it will also be added here in the dependencies. So now we have dependencies in place. Now it's time to go for creating the directories, and let's write the functions and deploy it, and let's see how this is going to work. So go to the index.ts and select Command A and delete everything from here, close this terminal, and first of all here you need to do to export and open the body. For that, here will be exported all of our functions that we want to deploy. So after this, Ctrl S to save this file, and next we are going to create some directories and some files where we will store our functions. So the first directory is going to be the core library or the directory, and the second directory is going to be the post, as we are going to scheduling a post, and in your case it can be anything according to your project requirements. So in the core directory, first of all we will create a Dart file, not a Dart file but the TS file. Here its name will be Firebase admin singleton.ts, and in here we will simply create the singleton for initializing the admin. For initializing the admin, we need an import and the Firebase admin.initialize and simply export the Firebase admin. So that was it for initializing the Firebase admin, and Ctrl S to save this file. And next in the post directory, let's go for creating a new file and name it schedule post ttl.ts. So here will comes our own create trigger, which will be triggered whenever we create a document in the TTL post collection. Here in the TTL post, whenever a single document is created in here, so the function we are going to write, the onCreate trigger, will be triggered and will schedule a task in the queue and will be dispatched after 2 minutes, or in your case it can be any time that you want according to your project requirement. So let's get started by writing the schedule post TTL on create trigger. First of all, here we need some imports. That would be the functions from Firebase functions and the Cloud Task Client for scheduling the task in the queue. Next, having these imports, we need to start writing the onCreate trigger. So we will do export constant schedule post TTL. We will name this trigger the schedule post TTL and simply will make it equal to functions dot from Firestore dot document. So now here we will pass the path to our document, like where the document when it's created. So this trigger will be triggered and schedule a task in the queue. So we will specify the path. First of all, we will pass the collection. So our collection name is TTL posts slash, and then in the wildcard the post ID. So when there in the TTL post on that post ID, when the document is created on that post ID, so simply we will call the onCreate trigger whenever the post is created in the TTL post on the post ID. Simply this triggered will be triggered, and this will be an asynchronous, will give us the snapshot and an arrow function upon the body, and that is how our schedule post TTL on create method is going to look like initially. To ensure that this method is called, simply you will write a console.log and some message inside. That will be schedule post TTL started. And then here we need some variables. First of all, we need the document data to deal with the post document that is created. So simply here we will create a constant variable for the post data to access the post document, and the post ID accessed from the same post data, the post that is created, and the expire seconds from the post data. I just named this expire millisecond to seconds, so you can name it expire milliseconds. because these are stored in the milliseconds epoch from the Firestore timestamp. So we got this basic variables in here. Now we need to calculate the time. So to calculate the time, we are going to have this, the expirations at second. We make it equal to expire seconds, that is the current time in the seconds. In the milliseconds, I just name it the expire seconds. So anyways, you can name it expire milliseconds. I just add 2 multiply by 60 and multiply by 1000. So it means 2 minutes in the future. And yes, you can send your timestamp from the client side or the application side so that you can use that timestamp to schedule the task in the queue using that timestamp. But I'm doing it just like this, just for showing you that how this process is going to work. So after having our expiration seconds in the future 2 minutes, next we need some information of the queue and of our project, so that will be used to create the task in that specific queue using that location and that project ID. So we also got the queue in here, and next now we need to initialize the cloud task client as we have imported in here. So let's go for initializing it in here. So after the task has been initialized, next we need an accurate path to the queue, so that will be used to create the task in that specific queue. So to create the specific or an accurate path in the variable, simply we will do, using this task client, we will create one more variable named queuePath. Its type is string. From the task client, queuePath, pass the project, the location, and finally the queue that we have created in the previous video. So having this queuePath, next we need a payload and the name of the task. So for that we will create two more variables. The payload, we pass the post ID in there, and the task name, the projects in the project locations, location, and the queues, the specific queue and the task. So now you might be thinking, why such a long name for the task? That is because the cloud tasks name use the hierarchical naming scheme in order to avoid the misunderstanding in the naming conventions of the cloud task, and also to avoid the unexpected behavior of the task. So just because of this, our task name is going to look like this. And next, the final thing that is required is to create the configuration or an object for the task and pass all of the data like the payload and the task name. So let's create also that. So our task is going to look something like this. The name, we pass the task name, that is simple a path to the tasks, and we name our task the my task. We pass the post ID and also the expire seconds for making it unique across all the other tasks in the queue. And also next we have used the HTTP request, so whenever this task scheduled time is completed and it's time for dispatch, so simply it will send request on the location in the project. On the cloud functions there will be a scheduler callback function and will send there a post ID as a query param. So we will access this query param in this post request, and using that post ID we will finally delete this task from the Firestore document. And here in the body we are simply sending a payload by simply buffer from JSON.stringify that and convert it into string by 64, and simple the headers are content type application JSON. So this is a simple task that would be created with this name, and this will send a post request on the scheduler callback and also send the post ID along with this whenever this time is completed. So after this we need to call only one last method to finally create the task in the queue, or also schedule the task, we can say, in the queue. So that method would be await task client dot create. In the parent, pass the specific queue path and the task we have just created. So by having this, we are done with our schedule post TTL on create trigger. So that will be triggered every time whenever in the TTL post collection there is a document created, and then we will console the log for ensuring that this trigger is called, and then we got some data of the post like the post ID and the seconds and then we calculate the time in the future for 2 minutes, and we also check if the expiration seconds was undefined. Simply do nothing and int the function by return nothing. Next, for the task creation, we need something like the project ID, the location, and also the queue name. And next, we initialize the cloud task client and also give a specific path of the queue and store it in the queue path variable. Next, we have a payload with the post ID and also a name which is following the hierarchical naming scheme of the cloud task. And then we have a task, we pass a name in here with this post ID and expire seconds for making unique across with other tasks in the queue. And this will every time send post request whenever this schedule time is reached on the scheduler callback, and in the scheduler callback we will simply access this post ID that we are sending, and using that we will finally delete the document from the Firestore. So that's how this scheduled post TTL method is going to work whenever there is a document created in that TTL post collection. So having this, simply Ctrl S to save this file, and that's it. Now one final thing here we have to do is to export this and default with the schedule post TTL name, because we are going to export it in the index.ts so that will be able to deploy. Next, Ctrl S in here to save it, and here now let's import this. Import the schedule post TTL from the module from the post from the schedule post TTL, and then simply pass the schedule post TTL inside. So that was it for this schedule post TTL function. Next, we need to write an HTTP function from SAM. This will be on request trigger and its name will be scheduler callback. So now let's copy this name, because this task will send the request on this scheduler callback whenever this time is reached. So we also have to create the scheduler task callback and access this post ID and finally delete the post from the Cloud Firestore database. So copy its name and go inside the post, create a new file and name it scheduler callback, and also let's rename it and give an extension to this .ts. And here we will do export constant scheduler callback will be equals to, let's go and copy the functions from here and paste it in here. This will be functions.https.onRequest, and there is going to be asynchronous, again the parenthesis, and inside this the request and response, the arrow function and the body open. So we are done with the scheduler callback creation. Now inside this we will access the post ID from the request, as whenever this is requested we are also sending the post ID. So we will access this post ID and using that we will delete the document from the Firestore. So let's go to the scheduler callback, and in here first let's access the post ID from the request. That is how we can access the ID from the request. Request query post ID as the string. So we got the post ID. Next we have to do put a try catch block and await from the Firebase admin from the Firestore collection the TTL post document on that specific post ID that we have received from the request. Delete that post from the Firestore document and send the response of 200 success. The post was successfully deleted. And also if there was some error, simply we will send the console log the error and the status response of 500 and send with the error. And also for this admin to access the Firestore from here, we also need to import the admin Firebase admin from the core Firebase admin singleton. Now Ctrl S to also save this scheduler callback. So having this, we are done with our scheduler callback also. From the schedule post TTL, whenever a post is created, we are simply scheduling a task for this. In the future, 2 minutes using this expiration at seconds. And here we are also doing the method floor in R2, remove the decimal values from here, and this required only the integer values. So we are using the expiration at seconds in here, and that expiration at second is in the future 2 minutes. So whenever a 2 minute has been passed, so this will call the scheduler callback and will delete the document from the Firestore database. So after this, let's go to the index.ts and also import the scheduler callback in here, scheduler callback, and from the post from the scheduler callback. So that's it. Now copy this and also pass it in the export. And there is one error from the scheduler post callback. That is because in the scheduler callback we also have to export default the scheduler callback, so this will also be allowed to import it in here. Now also save this and also save the scheduler callback with this default export. So having this, we are done with the schedule post TTL and also the scheduler callback. Whenever the post is created, this will be scheduled in the queue with a task and will be dispatched after 2 minutes, and the post will be deleted from the Firestore. So that was the only logic for scheduling a post in the future and also deleting it whenever the specific time is reached. And yes, you can also achieve your desired time that you wanted. So after this, it's time to deploy these functions and go for the actual testing. So let's open up the terminal, and here we need to first let's clear this, and for deploying the functions we will do firebase deploy and double hyphens only functions, but the colon and the name of the function that you want to deploy. So first of all, we will deploy the schedule post TTL and hit enter. So this will start deploying the function. So we have to wait some time for this. So when this is deployed, so then we will go for the testing. So the deployment of the first function, the schedule post TTL, has been completed, and now it's time to also deploy the scheduler callback function. So we will simply hit the up arrow button to take this command again and simply change its name to scheduler callback and hit enter, and also wait some seconds also for this. So whenever this final function is deployed, we will finally go for testing it, and you will see it how the cloud functions can optimize the UI and offload the tasks in the background and boost the performance of the application. All of the task execution works and their dispatch, all of the work will be in the background and nothing will be in the front end. So the front end will be optimized and everything will work fine, and post will be scheduled and will be deleted after 2 minutes in the future. So let's wait for it and see how this magic is going to inspire us. So the second function is also deployed, the scheduler callback. Now it's time to go and check them in the cloud functions of the Firebase and go for the logs tab, and then also go for testing them in the application. So after your functions has been deployed, simply you have to come to your Firebase console and come to this functions tab. You will find this in this build and simply open this functions. And here in the functions tab, you will see your functions that you have wrote and just deployed in here. The first one is schedule post TTL and scheduler callback. The one which is going to schedule a task in the queue, and this trigger is on create trigger. Here is its path, and the scheduler callback is an HTTP request which will be called whenever the schedule time is reached and it is time to dispatch. And also, if you want to see the logs of the schedule post TTL function and also the scheduler callbacks, here you will see the 3 dots. Simply click this and go for the view logs. So this will take you to a tab where you can see the logs, that what is going to happen. And you may also remember that we have console log a message in the schedule post TTL, so this will also be shown in there whenever this function is called when we create a post in the TTL post collection. So I already have opened the logging tab. So here is the tab of the scheduler callback. Let's restart this, and this is the tab for schedule post TTL. So you will see these 2 logs in here whenever the function is deployed. And now for this, there is also 2 logs because we have deployed these functions. So having this, we are going to take the eye on this schedule post TTL, because when we create the post, we also want to see that log that we have in the schedule post TTL here, schedule post TTL started. So we also expect that to see this in the logs. So let's go for our application and let's start testing this and see what is going to happen. So this is our application, and here we are going to create the post. We already have one created which will not disappear just because when we were creating this there were no logic of scheduling. So this will remain here, and let's leave it just like this and go for creating the new one. So we will name this, or we will write a description for this. We will say simply schedule post for 2 minutes 3 dots and simply go for uploading it. And this is uploaded. We got that post in here, and let's go for checking the logs and see what is going to happen. Here we are on the tab of schedule post TTL logs. Reload this page and go for checking the logs. We have only 2 logs and we have not seen anything yet. And let's also go for the queue to see if any task is scheduled or not. Come in here and let's also restart this tab to see if a task is scheduled or not. And after some loading, we will see a task, but unfortunately nothing has happened. There might be some problem with the code. So let's go and debug the code again and see what's the problem. So that is the code and the schedule post TTL. First of all, we are creating only the onCreate trigger. This is an asynchronous function which is called after the post is created in the TTL post collection. So we are console log the schedule post TTL started, and also getting the data of the post, obtaining the expiration seconds, and checking a condition, got the queue and the project details, initializing cloud task, accessing the queue accurate path, a payload, the task name and the task itself, and also finally calling the create task. I don't think there is a problem. The code seems to be right, and the scheduler call back is also correctly accessing the post ID from the request, and there is nothing wrong in this. So in your point of view, what can be the problem? In the schedule post TTL, we are creating the onCreate trigger on the TTL post time to live, TLL, time, live and live. Oh, I see. That is the problem, TLL. And let's also go for confirming it in the Firebase. Is that TLL or TTL? Yes, that is TTL, no, but not the TTL. So here we made the mistake. So we have to make sure this is TTL posts, not the TLL. So that was a problem, because of which we were not able to see any logs in here and no task in the queue, and nothing was scheduled. And that was because we are passing the incorrect name of the collection. So we have correct this TTL post. Let's also go for this and copy this and paste it in here to make sure now it's correct. So after changing this, now we have to redeploy this function and test this again. So I hope this time this is going to work, because the all code seems to be correct, and that was the only problem which was causing and were not allowing us to see any logs and any task schedule in the queue. So Ctrl S to save this file, and let's open the terminal again and run the same command of schedule post TTL and hit enter. Now we have to wait some time and the function will be deployed and we will be ready for going to the next test. So the schedule post TTL function is deployed again, and now let's go for checking the path in the Firebase. So we got in here, restart this, and we will see a path of TTL post and post ID. Now that seems to be correct. And now also here, reload this for seeing some other vlogs. And yes, we got 2 more messages logs of the function is deployed again. Now having this, let's go for testing it again. So these 2 posts will remain in here, and let's go and create one more post and say, hey, now I am really going to be disappeared. Upload this, and after it's uploaded, we got it in here. Now let's go and reload this. We got logs schedule post TTL started, so it means the function is successfully ran, and now it's time to check the schedule post TTL and reload this. And we got no task in here and got completed in last minute, and there is no post in here. It means that is directly dispatched and the post is deleted from the collection. That's weird. Okay, so let's go to the queue and let's refresh that queue after it's been refreshed, and let's go to the code. The code seems to be correct because the post was scheduled and was deleted before the time is arrived. So now after refreshing the queue, let's try it again by creating the post in here, and let's say this is new post for 2 minutes. That's it. Go for uploading. It's uploaded now. It's here. Let's go and refresh this queue, and the post is still here, not disappeared. And yes, finally we got the post schedule. That's the create time, and on the 3:44 and 51 second the post will be disappeared from the cloud Firestore. Let's go for also in here, and yes, we got the post, this new post for 2 minutes. So we have this, remember this, and that's the code. We have this task schedule in here, and that's the 3, 4, 4 and 5 1, and we have currently 3, 4, 3, and it's going 4, 6, 4, 7, 4, 8, and that's the post. So let's wait for it and let this time arrive to see some magic together. So only the 51 minutes, not the minutes but seconds, are remaining, and it's going 12, 13, 14 and like this. So let's wait some time for this. So only some seconds are remaining, and when it is reached, you can see the post is gone from here in real time, and there was no load on the UI. Everything was just optimized just like that and was amazing. There was no load on the UI and everything was done on the background, and task is deleted, and you can see we are no more able to see it in here. And let's go and make sure if it's deleted from the Firestore or not. So let's go to the browser, and here you can see we have only 2 posts, and there were 3 before when we came here. The post is of description to schedule post for 2 minutes, and yes, we know that that was the old one, and that is also the old one, hey, disappeared after 2 minutes, and that was the first when we just came here and there were no logic in there. And also go to the schedule post TTL queue and reload this, and there will no more task in here, and we will see nothing in here. The task is dispatched, the post is deleted, and that was all for scheduling the post in TTL in future 2 minutes. And yes, again, you can schedule a post at your desired time for your applications according to the requirements of your application. And yes, that was it for this episode, and in the next episode we will go for how we can cancel the already scheduled task from the queue. So we are going to perform some update operations, and according to that we will check if something is changed, and according to that we will delete the task from the queue and also delete it from the Firestore database. So yes, in the next episode, we will go for cancelling the already scheduled task. And in the final video after the cancelling task, we will be considering some potential issues related with the HTTP request, and you will also see it that how our HTTP post request is currently now not secure at all. So that's all we are going to do in the future 2 videos. Hello and welcome to the 4th episode of Google Cloud Tasks. So up until now, you learned what are Google Cloud Tasks and why you should use them and why they're useful. Along with this, you also learn how to set up the Google Cloud Tasks to use them in your application. And on top of that, you also write the cloud functions to make a Firestore document TTL. But what if we want to cancel the already scheduled task? That's where the things get interesting. So to achieve this, we have to include one additional field to the Firestore document that will be the status, the current status of the post. So we will update the status field using the Firestore regular update method to something like cancel, and we will listen to these update changes in the background as we are listening to the creation and schedule the task, and then delete it after 2 minutes. Same like this, we will listen to the update changes and check some conditions if it was updated to the cancels. So you will get some configurations like the project ID, the queue name, and the location, and all of that stuff to delete the task from the queue and also delete the document from the Firestore database. So that was the scenario we are going to achieve in this episode. So first of all, move to your browser and open the Firebase console in there and come to the TTL post. In your case, it can be any collection. So down here, I have a lot of fields in there, but I also included one field that is post status, and it's currently in progress. When I'm creating the post in the TTL post collection, I by default set the in progress means nothing. So using this post status, I will update this using some regular method of Firestore to something like cancel, and we will track these changes using the cloud functions on update trigger, and accordingly delete the task from the queue and also delete the post from the collection. So you have to include the post status or simple status, any name that you want. Next, now we have to write the onUpdate trigger to listen to the changes in that specific document if it's updated to cancel or whatever in your case. So accordingly, delete the task from the queue and also delete the post from the collection. So inside the post directory, we will create one more file of TypeScript, and simply we will name it cancel scheduled post.ts. So we got it in here. Now let's go to the schedule post TTL and copy the same two imports, because from the functions we are going to access the onUpdate, and using the cloud task client we will delete the task from the queue, and also we are going to require the Firebase admin to delete the document from the Firestore. So let's go to the cancel schedule post and here paste these, and let's go for creating the onUpdate trigger in here. So we got our cancel schedule post function like this. We got the functions Firestore from document. Whenever there is update performed in the TTL post collection on that specific post ID. So we got the snapshot, I just name it change, and inside this cancel schedule post we have to access the before updated data and the after updated data. So then we will compare them and accordingly perform the task that we want. So next, after the schedule post trigger onUpdate is created, now we want the data of after and before update. So we got this post before update, post after update. We access it like change before data and change after data. The before data is the data before update, and the change after data is the data which is the data after the update. So next, we are going to check some conditions accordingly and then perform our tasks that I said to delete the task from the queue and also to delete the post from the TTL post collection. So then we will check the condition if the post before update dot post status was not equal to the post after update status. We are comparing whenever the post status before update was not equal to the post status after update, and the post after update, the post status was equal to cancel, meaning that comparing the post status before update and the post status after update was not equal. It means the update is performed, and the update is performed after the post status was equal to cancel. So it means we are in the right place. We got the post status cancelled, and now it's not like before and it's updated to cancel. So now we will perform these two operations to delete the task from the queue and also delete the post from the Firestore collection. So we got this. Now inside this condition, we want the project ID, the location, and the queue name, and also to initialize the cloud task client. And next we need the task details, the post ID after update, and the expire seconds after update. And yes, these will not be updated. Accessing them from before or after doesn't even matter, because the update is only performed on the post status and it's updated to cancel, and it doesn't matter to access the post ID and expire seconds. It's actually the milliseconds from the post after update or post before update. So we got the post task details, that's actually the post details, not the task details, the post ID, and the expire milliseconds. Next, we want a task name in the project, in the specific project, the locations in the specific location in the Google Cloud Platform, in the queues in the specific queue that we have passed schedule post TTL, and also in the tasks there is my task as we name it, and the post ID that we have specified while creating it, and also the expire seconds. And after that, we will call await Firebase admin from Firestore collection on the TTL post collection on the specific post ID that we have obtained, delete the post in here. And finally, await task client, delete the task from the queue using the specific task name. And also, here we have to import the Firebase admin just like this to use the Firestore collections and TTL posts just like that. So having this, we are done with the schedule post TTL update trigger. So whenever an update is performed and the post status is updated to the cancel, so this function will listen to the changes and delete the post from the Firestore database and also delete the task, the already scheduled task from the queue. And now we have simple to export default and the name of the cancel schedule post here, and are to export it and accordingly deploy the function and go for testing. And also here you might be thinking, for obtaining the task name we have done this long process, access the task name and also obtain the queue location and the project. You can also do something like this. According to the blog post I wrote in the Medium, you can get their links from the video description. So let's come down here and go to the portion of where we are canceling the cloud task. Here is canceling scheduled task. So first of all, here is the code for that is the code of what we are doing currently for deleting the task and also deleting the post. So down here I'm saying you can also do this something like, while creating the Google Cloud task, you can store the response of the task client in some variable, and from this response access the response.name, meaning that the task name, and update your collection the task name to the task name, meaning that store the task name in your Firestore database. So for that you also have to create one more field of task name and include the task name in there while creating the task. So after that, the task will be created and it will store the task name in your Firestore database. And then you have to only do just this, and you don't have to access the project ID, the location and the queue name and also the long task name to delete the task. But instead you already have the task name stored in the Firestore database. So simply access it from the event after update. In this case, in our case, it will be post after update, and pass it in here, so this will become really simple. So also if you want to go at your own pace, so simply you will get the link of this blog post in the video description, so surely you can go at your own pace by reading these articles on Medium. So having this, we are done with our cancel schedule post, and now we have to Ctrl S to save this file and go for index.ts and import this cancel schedule post from the post cancel schedule post and simply pass it here in the export, and we are done with this. Now it's time to deploy this function finally and go for testing it. So open up your terminal, clear everything and run firebase deploy only functions cancel scheduled post. Hit enter and it will start deploying the function, and we have to wait some time for that. After it's deployed, then it will be the time for going to test it in the application. So after the function has been deployed, let's go for checking it in the Firebase functions tab and also go for testing it. So in the Firebase functions tab, we got one more function cancel schedule post. It's the document.update. It will be performed in the TTL post on the specific post ID whenever there is an update, and the update was to update the post status from the in progress to the cancelled. And the other updates, like whatever you want to some other updates, will not work for this, but this will only work for whenever the post status is updated to the cancel, because we check the conditions and inside the conditions all the cancellations and deletions are performed. So the updates of this field to some other data is not going to work at all, but you have to update it to cancel in order to achieve your desired results. So we got this cancel schedule post, and when you open its logs, you will see 2 logs in here of deployment of this function. So here we have 2 logs, and now it's time to go for scheduling a task and then update the Firestore post status field to cancel and see what's going to happen. So now let's go for testing it. Write some description in here. Let's say this post is going to be deleted before 2 minutes, because we are going to update it and it will be disappear right away before 2 minutes has been reached. So let's upload this, and we got this post in here, and let's refresh this, and we got this task scheduled. It will be disappeared when it's 1:06:43 seconds, and let's go to the Firestore, and this is the post. Let's update its in progress to cancelled and update this, and this post is updated to cancelled, and you can see in real time it's deleted from the Firestore from here. And also let's go to the schedule post TTL task. Let's refresh this, and it's also deleted from here, and the task is deleted. Now let's go to the application, and you can see that post is not in here. So it means we have successfully cancelled the already scheduled task by using simple one additional field of status to track the status. If it was updated to something else like the cancel, simply track these changes and obtain the data of the queue and also the post, and delete the post from the Firestore and also delete the task from the queue, and that's it. And in the next episode, we will be finally going to consider one big potential issue related with the post request of this here in the post TTL, where we are sending the post request on the scheduler callback. So the issue here is when we schedule a task in here, anyone with just internet connection and our payload patterns and the things like the params we want can delete the post from our Firestore collection, and there is no security around this. So we have to secure this by some required stuff in here. We have to authenticate the function invoker using a service account of Google Cloud Platform, and only that service account will be required to call that post request, and not all the other individuals will be allowed. So that is what we are going to achieve in the next episode. Hello and welcome to the final episode of Google Cloud Tasks. So you know how to make a Firestore document TTL, and you also know how to cancel the already scheduled task. But you left one thing, that is the HTTP post request we are sending on the scheduler callback to delete the document from our Firestore database is not secured at all. By saying that it's not secured, I simply means anyone with just internet connection and the pattern of my HTTP post request can delete the post from my Firestore database. So do you want to see the demo of the application? Let's have a look. So we have this simple application again. Let's go for creating one post in here. Let's say schedule post 123 and let's go for uploading this. So we got this post in here. After refreshing the queue, we got this post schedule on 12, 12 and 44 seconds. So this will be deleted from the queue on that specified time. But let's go and send request on the scheduler callback HTTP post request to delete the post before its time is arrived to test it how this HTTP post request is not secured. So let's go and click this post and copy its post ID from here and open up your Postman, a simple API tester, and paste the scheduler callback URL in here. Your location will be in here and your project name and the scheduler callback trigger name, and in the post ID simply paste the post ID in here. And let's go for sending the post request on this, and we got the post was successfully deleted, which is the response of the scheduler callback, the success response of the scheduler callback when the post is deleted from the Firestore database. So in the application, the post is deleted, and here when we refresh this, there will still be the task remain in here, and this task will be remain in here until its specified time is arrived, and then it will be dispatched from here and it will look for deleting the post. But if there is no post, it will be simply dispatched and disappear from here, and also can throw the entity not found error in the logs. So anyways, we have seen how our HTTP post request is not secured. Anyone with just location and the project ID, the callback name and the post ID can delete the document from our Firestore database as we have deleted right now for testing. So in today's episode, we are going to secure this HTTP post request so no one outside will be allowed to delete the post from our Cloud Firestore database. Now, when we refresh this queue, its time is reached, so there will be no task in the queue. So you can see the task is not in here just because its specified time was arrived and it was dispatched from here. So to overcome this issue, we have to manage the schedule post TTL and the scheduler callback in a different way in order to attain such security for the HTTP post request. First of all, we will authenticate our function invoker using the service account and then checking some specific conditions to allow only the authenticated request to delete the post from our Cloud Firestore database. So before going forward and creating the service account, let's understand the concept of service accounts in the Google Cloud Platform. In Google Cloud Platform, a service account is a special type of account which represents a non-human entity such as an application or a virtual machine instead of an individual user. And these accounts are mostly used to authenticate and authorize various resources in the Google Cloud Platform. So we will be using these service accounts in our schedule post TTL on create trigger to generate the OpenID connect token or OIDC token whenever it's time for dispatch or send the request on the scheduler callback. So while sending the request on the scheduler callback, the OpenID connect token generated with the service account will be included in the authorization headers of the request. So later in the scheduler callback, we can grab that token from the authorization headers and verify that token. So if it was verified, we will allow the request for further processing to delete the post from the Firestore database. Otherwise, we will neglect the request and send the error message of 401 unauthorized token. So in that way, we will secure our HTTP post request from outside world to not allow everyone with just internet connection to send the request on our HTTP post request and delete the post from our cloud Firestore database. So that was the scenario we are going to achieve in today's episode. So having this in mind, let's go for creating a service account. So to create a service account, simply you have to navigate to your Google Cloud Console and simply go for navigation menu, where you will find the IAM and admin, identity access management and admin. Open it in the new tab. After it's open, in the first tab you will see all the default services accounts created of your project. Simply you have to ignore all of them. Each one service account is doing their own work. So we are going to create a service account that will be only used for to authenticate the function invoker, so that only that service account will has the right to generate the OpenID Connect token and include it in the authorization header, so later we will be allowed to access it from the authorization header and verify that token. So to create a service account in the IAM and admin, simply you will find the service account tab. Click this to navigate here and you will find a button of create service account. Click this and go for creating a service account. You have to simply name your service account according to what task you are going to perform. So we are going to perform securing our HTTP post request, so we can simply name it secure my Google Cloud task or whatever you like. And also the service account will be generated directly when you simply name your service account and simply write a short description for your service account, that for what you are creating a service account. So after this, the other two options are optional, so simply you can just go for next and create your service account. So after your service account is created, you have to come to again your IAM, identity and access management first tab, where you will find your service account. So simply I have already created one, secure my Google Cloud task, and I have granted 4 roles to this account. So to grant roles to your service account, here you will find the grant access. Click this and in the new principal type your service account and grant the role to it. But instead, if you have already created service account in here, you can go for edit and grant the roles in here, like add another role and go for in here, search for the role you want to give to your service account and go for saving it. So you have to give 4 roles to the service account you created. The first role will be the Cloud Functions Invoker, the ability to invoke HTTP functions with restricted access, and also the Cloud Task Admin with the Cloud Task Enqueuer to enqueue the task in the queue, and finally the Service Account Token Creator. That will be that token created and included in the authorization header of the request. So this role is for creating that OpenID Connect token and later to include it in the authorization headers. So in the scheduler callback, we will grab their token, verify that and allow the request for further processing. So after your service account is created with these certain 4 roles, the Cloud Function Invoker, Cloud Task Admin, the Cloud Task Enqueuer and Service Account Token Creator. So you are ready to go and modify your scheduler callback and also the schedule post TTL to secure our HTTP post request. So let's open up your VS Code again just like this and go to the schedule post TTL. So in the schedule post TTL, we have to add our service account in a constant variable. So let's go for adding it. So we got our service account email equals to the same secure my Google Cloud task and again the project ID iam.gserviceaccount.com, the same service account that you have created and provided certain roles to it. Simply create this. So simply paste that account in a string and store it in a variable like service account email. And next thing you have to do is to configure your task. So in the HTTP request after the headers, we will do one more thing in here. That will be to include the OIDC token field also in here, it accepts the map, we pass our service account and then the audience of the same service URL excluding the query params. The audience field in the OIDC authentication ensures that only intended recipient can accept and verify the token, and in our case the intended recipient is our scheduler callback. So for more detail to know about the audience field, you can read my article on Medium. You'll find the link in the video description. So after having this OIDC token included in your task, that was it for the modification of schedule post TTL in here. So you have to go for Ctrl S to save this file, and let's go for modifying the scheduler callback. So before going forward and modifying the scheduler callback here, let's understand again that scenario. We have put our service account in the variable and pass it in here, and also the audience field in here to ensure that scheduler callback is our intended recipient and only scheduler callback can verify and accept the token. So whenever it's time for dispatch and send the request on the HTTP post request only from our application side where we have added the service account and generating this OIDC token, only that side will have the ability to include the token in the authorization header. So in the scheduler callback, we will access this token and verify it and allow the request for further processing. So no one outside will be allowed to come in here because they don't have the token generated. So that way we are securing our HTTP post request, and you will also see after we write some code and deploy these functions and test them again. So after having this in schedule post TTL, let's go for the scheduler callback, and here after the post ID we need two more fields. That will be the project ID and the location. Because we are going to verify the tokens, so we need the same audience that we have passed in here. We need the same audience URL. So for that we also need the location and the project. So in the scheduler callback we also have to pass the fields of project and location. Let's copy it from the schedule post TTL and paste them in here. So we are gonna need them for the audience to verify the upcoming token from the request of schedule post TTL. So next thing in the schedule callback, we are gonna do access the authorization header from the request, and next print it in the console. And surely you have to avoid console logs in your production application. I'm doing it just for testing it. So next, check if authorization header was not null. If it was null, simply we will console log unauthorized token and also send a response of unauthorized token. But in other case, if the authorization header has the token, so we will go for the verification process. So for verification, surely we have to access the token from the authorization header. So to access it, we will do access the token from the authorization header just like this and store it in the token variable. And we are accessing the token from the authorization header by splitting it with a space and accessing it by 1. That is because the format of token in the authorization header is just like that. Next, we will also again console log the token. So after the token has been accessed from the authorization header, let's go for verifying process. So we will go through one more try catch, and here we will await verify the token, passing the token, location and the project for the same audience, and then console log token verified, in other case unauthorized token, console log and send the response of 401 unauthorized token, return to end the function, and do not allow the request for further processing to delete the post from our cloud Firestore database. So now let's go for implementing this verify ID token. So outside this scheduler callback, we will do create an asynchronous function verify ID token. It is accepting the token string, location and the project of type any. And then we are accessing the OAuth2 client. So this will be accessed from the Google Auth library that I told you we are going to use in the final video of this series. So let's import also this just like that. So we got OAuth2 client from the Google Auth library, and now the error is gone. Next, from the OAuth2 client, we are verifying the ID token that is coming from the authorization header generated with the service account in the OIDC token field in the task configuration while dispatching and sending the request on the scheduler callback. So we are verifying that ID token, passing that ID token in here and the same audience in here. So we are saying we are the same audience that you meant for and we are the intended recipient to verify and accept the token. So here we are verifying the token by passing the same audience service URL that we have passed in the schedule post TTL. So after this, whenever the token is verified, we are simply returning ticket.getPayload. Next, in here, the error is gone from here. So what we are doing in here, accessing the post ID from the request for deleting the post from the Cloud Firestore database. So we got the project location for the audience field. We got the authorization header from the request, console log it. If the authorization header was null, simply we will say there is no token found. So we will again send 401 error message that unauthorized token. And then if it was not null, so it means the token is here. So simply we'll access it just like that and verify the token and console log the way token is verified. Go for deleting the post from the Cloud Firestore database with the 200 success response. The post was successfully deleted. In other case, unauthorized token 401 error message. So that was it for also verifying the token in the scheduler callback trigger. So in the schedule post TTL, whenever it's time for dispatch, only from our application side, it has the ability to include the OIDC token in the request authorization header and the scheduler callback. We are grabbing that token. If it was null, we are sending the 401 error message, and also if the verification fields and the token was not verified, it means it's some incorrect token. So in that case, we are also ending the function by simply returning and sending the response of 401 unauthorized token. So that's it for this, and now Ctrl S to also save this file, and let's go for deploying the functions and testing them. So go to your index.ts and Ctrl S in here, open up your terminal, clear the terminal, and let's go for Firebase deploy only functions. First we will go for schedule post TTL, and then we will go for scheduler callback and then go for testing. So we have to wait some time for that. After it's done, we will go for testing and send the request on our post request to check if our post request is secured or not. So our schedule post TTL function is successfully deployed. Now let's go for deploying the scheduler callback also. So simply remove the name of the schedule post TTL by pressing the up arrow button, and let's go for scheduler callback. So that is the final function. After it has been deployed, we will go for the final testing of the application to check how our HTTP post request is secured now. So after the functions has been deployed, let's go for the logs tab to check how is it going. So in the scheduler callback logs tab, we got two messages. It means our function is successfully deployed, and also for the schedule post TTL, the same is going on in here. The two log messages, it means it's also successfully deployed. So now let's go for our application and let's create one post, schedule it, and let's send the request on it to see what is going to happen. So let's create a post and say schedule post, and let's go for uploading it. Here we have got it, schedule post, and let's go to the schedule post TTL queue, refresh the queue, and let's get the ID from the task for sending the request. So open up your Postman again and click the search bar, paste your ID in here and send the same request. Now this time send the request, and we got unauthorized token. We are unable to send request in here. That is because we have now secured our HTTP post request. So no one outside, even ourselves, if we don't have the authorization token, we cannot send the request to delete the post from our Cloud Firestore database, but only our application has the right to generate the token include it in the authorization headers of the HTTP post request, and later we are accessing it in the scheduler callback. It will verify the token and allow for further processing and delete the post from our Cloud Firestore database. So you can see I have passed the ID in here and we get the unauthorized token response that we don't have any token in the authorization headers and it's empty. So we are not allowed to send the request in here. And we also, if we pass, let's say beer and let's say this and send the request, it will again say unauthorized token because the token is again unauthorized and it is not the generated token, so it will again say the unauthorized token. So now if we go and check our application, the post is deleted from here. That is because we are scheduling the post in future 2 minutes, so our application has the right to delete it whenever the time is arrived. So you have seen the token was generated whenever it's time for dispatch, and the scheduler callback has verified the token and the post was deleted from here. Only our application has the right to do it and it did it. And when we were trying to delete it from outside, we were getting an unauthorized token 401 error that we do not have the authorization token in the header, so we are not allowed to send the request on this and delete the document from Firestore database or anything in your case. So that way we have successfully secured our HTTP post request, so only our application has the right to generate a token, include it in the authorization header and map it in the scheduler callback and verify it and go for further processing, and no one outside is allowed to delete the post from our Cloud Firestore database. And that's how we secured our HTTP post request. So let's go for the queue, refresh the queue, and there will be no queue because it's dispatch and our application has the right to do it. And let's go for the logs in the scheduler callback. We will also see some errors in here because we have sent the request on it. Here you can see whenever we send the request, we got the unauthorized token because that was us was sending the request. So we don't had the token in the authorization header, so we were getting the unauthorized token 2 times. And next time when the time is arrived, when our application include the token in the authorization header, so simply you can see here it logs in here the authorization header with the bearer and the token, and then also printed the token, a token verified, the function execution started, and the post was deleted from our Cloud Firestore database, and that request was from our application side, so it's done and the post was deleted. But in other case, whenever we try to send the ASD and ASD bearer token, you can see we got again the wrong number of segments unauthorized token and then the error. So that way, after seeing the logs, it's confirmed that we have secured our HTTP post request and no one outside is allowed to send the request on it and delete the post from our Cloud Firestore database. So along this series, you'll learn what are Google Cloud tasks, how to set up them, and how to utilize them to make our Firestore document TTL, and also how to cancel the already scheduled task, as well as taking care of our HTTP post request security. So that was all you need to know to implement it in your application without any headache. So now feel free to use Google Cloud Tasks in your applications, and there is no need to get mad on this because everything is secure and you don't need to worry about anything. So before ending the video, follow eTechViral on LinkedIn and Instagram. You'll find the link in the video description where we upload informative content on daily basis. So I hope you have enjoyed the video. Like and subscribe to eTechViral and are to get notified whenever the amazing videos are uploaded. So that was it, and see you in the next video.